The story of Sagittarius A, the supermassive black hole lurking at the heart of our Milky Way, is a testament to humanity's relentless pursuit of the unseen. As detailed in the original content, this invisible behemoth, with a mass equivalent to about 4 million suns, crammed into a space smaller than our solar system, remained hidden for centuries behind a veil of interstellar dust and gas. The galactic bulge, a dense swarm of hundreds of billions of stars, acted as a natural barrier, scattering visible light and confounding early astronomers. This obscurity wasn't just a physical challenge. It symbolized the limits of human perception until technological ingenuity pierced the darkness. The journey began inadvertently in the 1930s with Carl Jansky, an engineer at Bell Labs, tasked with troubleshooting radio static for transatlantic communications. His rotating antenna, whimsically dubbed a merry-go-round, picked up a persistent signal from the direction of Sagittarius that synced with sidereal time, not solar cycles. This accidental detection birthed radio astronomy, revealing a universe invisible to optical telescopes. Grote Reber's backyard parabolic dish in the late 1930s confirmed and mapped these signals, highlighting Sagittarius A as a compact, intense radio source. By the 1940s and 1950s, as radio telescopes proliferated, the galactic center emerged as a hotspot of enigmatic emissions, distinct from stellar remnants or nebulae. Yet, the dust wall persisted. Visible light telescopes, akin to giant eyes, faltered against interstellar particles that absorbed and scattered photons. The breakthrough came with infrared astronomy in the mid-20th century. High-altitude balloons, aircraft, and mountaintop observatories like Mauna Kea bypassed atmospheric absorption, unveiling hidden star clusters and heat signatures. NASA's Infrared Astronomical Satellite, IRAS, in 1983 mapped the infrared sky, exposing warm dust and nascent stars in the bulge. Later, the Spitzer Space Telescope in 2003 delved deeper, capturing swirling stars around an invisible point. Sagittarius A. Parallel advancements in adaptive optics revolutionized ground-based observations. By the 1990s, teams led by Reinhard Genzel and Andrea Ghez employed this technology at the Very Large Telescope in Chile and Keck Observatory in Hawaii. Adaptive optics used deformable mirrors, adjusted hundreds of times per second via laser-generated guide stars to counteract atmospheric turbulence. This precision tracked the S-stars, like S2, orbiting at speeds exceeding 5,000 kilometers per second. S2's 16-year elliptical path, observed fully by 2002, yielded irrefutable evidence: an unseen mass of 4 million solar masses, behaving precisely as Einstein's general relativity predicted, with space-time warping and orbital precession defying Newtonian gravity. The pinnacle arrived with the Event Horizon Telescope in the 2010s. This global VLBI network, linking dishes from the South Pole to Alma in Chile, simulated an Earth-sized telescope. Observing at 1.3 millimeter wavelengths, it captured Sagittarius A's radio glow in 2017, releasing the iconic 2022 image, a blurry orange ring encircling a dark shadow, the event horizon's silhouette. This wasn't just visual confirmation. It validated black hole theory, measuring the Schwarzschild radius at about 12 million kilometers. These advancements underscore a key strength of the original content. Its chronological narrative weaves technology with discovery, showing how each tool, radio, infrared, X-ray, for example, Chandra Observatory's flare detections, built on the last. However, it glosses over controversies like data interpretation debates. Early radio signals were dismissed as noise, and EHT's image required averaging variable emissions, sparking discussions on whether it truly photographs the unphotographable. In 2025, with upgrades like the next-generation EHT and James Webb Space Telescope's infrared prowess, we're refining these views. JWST's recent galactic center maps reveal finer gas dynamics, hinting at past activity. This evolution from obscurity to imagery not only demystifies Sagittarius A, but also highlights astronomy's collaborative spirit, turning cosmic silence into a symphony of data. A cosmic predator, silent and immense, coiled at the heart of our galaxy. Its gravitational jaws capable of devouring stars in a single gulp. Sagittarius A star, this supermassive black hole, isn't just a void. It's a gravitational titan with a mass of 4 million suns, squeezed into a sphere barely larger than Mercury's orbit. Its event horizon, the infamous Schwarzschild radius of about 12 million kilometers, marks the ultimate point of no return, where light itself surrenders to an inescapable pull. But in a universe teeming with raging quasars and voracious giants, Sagittarius A plays the role of the brooding enigma, eerily quiet, yet harboring secrets that could erupt into galactic chaos. As of October 2025, fresh discoveries, like blistering hot winds blasting from its core and hints of a long-lost companion, have ignited fierce debates, transforming our understanding from a static portrait to a thriller of cosmic intrigue. At its core, Sagittarius A exemplifies the supermassive black hole class, one of several breeds that defy imagination. Stellar mass black holes, born from the cataclysmic deaths of massive stars in supernova explosions, are the compact underdogs, mere kilometers across, but packing solar masses into pinpoint densities. They lurk in binary systems, siphoning gas from companions in dazzling X-ray displays. Intermediate mass black holes, elusive bridges weighing hundreds to thousands of suns, might form in dense clusters through mergers. Though their scarcity fuels controversy, are they the missing links in black hole evolution, or rare anomalies? Then come the supermassives, like Sagittarius A, titans from millions to billions of solar masses, anchoring nearly every galaxy's center. Theories clash on their origins. Did they collapse directly from primordial gas clouds in the universe's infancy, or grow through frenzied mergers and accretion? Primordial black holes, hypothetical relics from the Big Bang's density fluctuations, add speculative spice. Some whisper they could be dark matter's hidden face, though evidence remains ghostly. Ultramassives, exceeding 10 billion suns like TON 618, push boundaries further, their event horizons spanning light weeks, challenging growth models in a universe only 13.8 billion years old. Job: Sagittarius A's properties amplify the drama. Unlike blazing quasars devouring matter in radiant accretion disks, it's a quiet giant, feasting sparingly on sparse gas, producing faint radio whispers and sporadic flares. Magnetic fields twist like serpents near the horizon, storing energy that unleashes X-ray bursts, sudden, unpredictable tantrums lasting hours, possibly from gas clumps or field reconnections. Yet, 2025's bombshell revelations crank up the tension. Astronomers, using NASA's Chandra and other observatories, finally spotted hot winds erupting from Sagittarius A, a long-predicted outflow of superheated gas at millions of degrees, blasting outward at breakneck speeds. This missing wind, detected in October 2025, suggests Sagittarius A isn't as dormant as thought. It's venting energy, perhaps regulating its own hunger. Echoes in nearby clouds hint at a violent past, with flares hundreds of thousands times brighter mere centuries ago, raising alarms. Could a gas cloud or stellar disruption awaken this beast, turning our galaxy's core into a quasar inferno? Controversies swirl like the orbits of its captive S-stars. Why does every galaxy host a supermassive heart, a mass bulge correlation? Black holes scaling precisely with galactic bulges implies a symbiotic dance, where black holes' feedback jets and winds sculpt star formation. But mechanisms remain hotly debated. Sagittarius A's relative puniness compared to M87's 6.5 billion sun monster, or TON 618's 40 billion sun colossus, questions growth limits. Did mergers with dwarf galaxies bulk it up, as a March 2025 study proposes, potentially including a swallowed intermediate companion? This companion hypothesis stirs excitement and skepticism. Evidence from orbital anomalies is tantalizing but inconclusive. Future activity looms as a powder keg. The impending Milky Way Andromeda collision, in billions of years, could funnel gas inward, igniting quasar fury. But timelines and impacts on habitability spark ethical debates. Even JWST's September 2025 images of Sagittarius B2, a star-forming frenzy nearby, underscore tensions. Does Sagittarius A's gravity nurture or stifle life in the galaxy? These properties and puzzles don't just inform, they electrify astrophysics, blending Einstein's relativity with quantum mysteries at the singularity's edge. Sagittarius A isn't a relic, it's a live wire. Its controversies challenging our cosmic narrative. A universe teetering on the edge of oblivion, where colossal voids like Sagittarius A dictate the fate of galaxies, stars, and perhaps life itself. This isn't science fiction. It's the chilling reality unveiled by our deepening gaze into the Milky Way's core. As of October 28, 2025, with blistering hot winds finally erupting from Sagittarius A's maw and whispers of a devoured companion echoing through the cosmos, the implications explode like a supernova. No longer a dormant shadow, Sagittarius A emerges as a cosmic architect, or destroyer, shaping the universe's grand narrative, forcing us to confront terrifying questions. What if this quiet giant awakens? How does its gravity entwine with the birth and death of worlds? And in the race against time, can humanity's ingenuity unlock the final secrets before the stars themselves fade? The stakes couldn't be higher. Supermassive black holes like Sagittarius A aren't mere curiosities. They're the gravitational overlords governing galactic evolution. Their immense pull orchestrates the swirling dance of stars and gas, forging the spiral arms of galaxies like ours. But here's the twist. Recent detections of those elusive hot winds, clocked at millions of degrees and blasting outward at ferocious speeds, reveal Sagittarius A as a regulator of chaos. Announced in early October 2025 by teams using NASA's Chandra X-ray Observatory. These outflows, long predicted since the 1970s, vent excess energy, preventing catastrophic overfeeding. Imagine a predator exhaling fire to temper its hunger. Without this, Sagittarius A could devour surrounding matter unchecked, stifling star formation across vast swaths of the Milky Way. This feedback mechanism, now confirmed, explains why our galaxy remains a fertile cradle for stars rather than a barren wasteland. Yet it raises a heart-pounding paradox. If these winds weaken, a feeding frenzy could ignite, transforming Sagittarius A into a quasar beast, spewing radiation that scorches planetary atmospheres light years away. Articles from outlets like Science and New Scientist in October 2025 speculate this could have happened centuries ago, with X-ray echoes in nearby clouds as ghostly evidence, a reminder that our quiet black hole might be one gas cloud away from apocalypse. Zoom out, and the drama intensifies. Sagittarius A's existence implies a universal blueprint. Nearly every galaxy harbors such a monster, their masses eerily synced with host bulges in a symbiotic lockstep. This correlation, observed across billions of light years, suggests black holes aren't accidents, but essential engines, birthed in the Big Bang's fiery aftermath, or forged through mergers. The March 2025 revelation from AAS Nova adds fuel to the fire. Sagittarius A may have once had an intermediate mass companion, swallowed during a dwarf galaxy merger, bulking it up like a cosmic cannibal. If true, this hints at a violent history, where black hole duets spiral into cataclysmic unions, rippling gravitational waves detectable by LIGO. But controversies rage. Skeptics argue the orbital anomalies supporting this are artifacts of dust, not proof. Meanwhile, primordial black holes lurk in the shadows, potentially composing dark matter, the invisible 85% of the universe's mass. If Sagittarius A seeded from such ancients, it ties our galaxy to the dawn of time. But proving it demands detecting their evaporative Hawking radiation, a quantum ghost that defies observation. Life's fragility hangs in the balance. In a galaxy teeming with billions of stars, Sagittarius A's subdued state might be why Earth thrives. An active phase could bombard us with gamma rays, stripping ozone and triggering mass extinctions. Echoing Marca.com's October 26, 2025 warning of reactivation threats. Yet, September 2025's James Webb Space Telescope images of Sagittarius B2, the galaxy's largest star-forming cloud, just hundreds of light-years from Sagittarius A, paint a hopeful thriller. JWST's infrared pierced through impenetrable dust, revealing vibrant nurseries of massive stars amid dense voids that even it can't fully penetrate, per NASA and CBS News reports. This proximity to doom fosters creation. Gravitational tugs from Sagittarius A compress gas, birthing stellar giants. But tension builds. What if a flare disrupts this? The information paradox adds existential dread. Black holes swallow data, violating quantum laws. Yet Hawking's evaporation suggests they leak it back, blurring reality's edges. The future? A high-stakes quest pulses with urgency. EHT upgrades, slated for 2026 observations, promise sharper shadows, decoding Sagittarius A's spin, a whirlwind that could launch jets, piercing interstellar voids. Space missions like ESA's LISA, launching in the 2030s, will eavesdrop on merger waves, confirming companion theories. AI-driven simulations, fueled by 2025's wind data, model awakening scenarios, while ground arrays like ALMA probe accretion's chaos. But dangers loom. Ethical debates swirl over AI hallucinations in data analysis, and funding wars pit black hole hunts against climate crises. Imagine detecting a rogue intermediate black hole barreling towards Sagittarius A, a merger that reshapes our galaxy in eons, but detectable now. In this cosmic theater, Sagittarius A isn't just a black hole. It's the villain hero of our story, whispering warnings of entropy's triumph. As we stand on discovery's precipice, one flare could rewrite everything. Will we unravel the universe's code or succumb to its darkness? The clock ticks. Humanity's greatest adventure awaits.